Welcome back to the Advent of Sintran 2025. We're coming up on day 7. Let me check my stream, make sure I'm live, make sure my mic is working. And it is working. I mean, obviously, I should trust just looking at OBS and knowing that the audio is active there, and then assuming that that passes through and that my audio is actually working for real, but better safe than sorry. So that's the first thing I do every stream. Got a minute and a half, a little over a minute and a half until the puzzle unlocks. So not much to do before then. I think my chatbot is running as usual. I've got everything. Whoa, where did I just type? Got everything ready to go. So, just waiting for the puzzle to unlock. One minute. I feel like the puzzles aren't getting significantly harder, but it might be like a frog being boiled. What if they get harder so slowly that you don't really notice it? But then, like, if you jumped in several months later and just randomly tried a day 7, you might think, oh, this is kind of difficult. But with this gradual ramp up, like, they get harder, but you're also, like, building skills and remembering how to do things and remembering how to use your own utils or helpers. So they get harder, but you also get better. So it doesn't really seem like they get that much harder, even though they might, in fact, in reality, be getting more difficult. So hopefully I'm not up until like 2 a.m. or 3 a.m. or whatever. Just about time. Let's do this. Download my input. Looks like a grid problem. This is day 7. Let's get the test input. Tachyon beams. Oh, is it like the Hall of Mirrors from a year or two ago? Oh, they're splitters or something. It's more like a waterfall problem. We've had those before too. And I got an extra blank line from copying and pasting, but that's not actually there. So no blank lines in this input. All right, now my template should just echo that test input. So that is ready. Now let's figure out what we're doing. Teleportation. Magic smoke. Oh, that's a Wikipedia link. I thought that might be like a throwback to the puzzle from the previous year, which was kind of similar. Maybe. I haven't read this yet, so maybe it's not similar. Oh no. Tachyon manifolds. So start, and the beams go down. They go through empty space, but at the splitter, they go down to the left and right. This is going to be like a depth first or breadth first search. Oh, they're immediately to the left and right, not down and to the left and right yet. So here you don't get 4, you get 3, because 2 of them happen to be at the same place. Yeah. How many times will the beam be split? Well, that's an interesting question. So we don't really care that they're merging into a unique thing. Well, I guess you do, because if you count if you then count this as getting split once versus split twice, that's important. So yeah, we're gonna do like a breadth first or a depth first search. We're gonna have like a grid of places that we've been before. And I think I'm just gonna do this recursively. I did not have, was it just a year ago that I didn't have recursion? I now have recursion in Syntran. So this is something that I can do. All right. Let's load a character matrix. And print it out. That's a reference to the matrix. So we get the ampersand in Syntran like you would in C-like languages. All right, there's our character matrix. Now we start at S, and we're going to go down. So, depth first or breadth first? I don't really care. Maybe I'll just call it search. Search. We're going to search on the character matrix. We're going to need to find the location of the S. So we're going to have a starting location x, y, naught. And we're going to keep track of the number of splits. I think that's going to be my function signature. So we're going to have a grid, which is a reference to a string matrix. And we're going to have the initial location as a vector. Yeah, let's do vectors, and then we can have like a directions. No, yeah, well, let's go to scalars. These are integer indices, the x and y position that we're searching from. How big is this input? Not like astronomically large. Bigger than the test input, of course. Okay. We're going to want the size of the grid, nx, ny. And if grid xy equals capital S, then break. Print line. I don't have n split. This is a void function, but it still has to return. So we start at 7, 0. That seems reasonable. X is 7, Y is 0 with 0-based indexing. And the top row is Y equals 1, and then Y goes positive downwards. That's the convention that I usually use for these grid problems in Advent of Code. Now we need a recursive search. So we have the function stub, but we have to fill this out. So usually we go down. So we're going to get the character that we're currently on, C. And then if C is not a splitter, we're going to go down. And if C, if we've already been here, we're going to return. Yeah, that should be fine. I hope. Do we need to do this? Maybe. I'm going to assume we don't have to do that. So here let's be positive about this. Otherwise we go straight down. Y plus equals 1. And then search, same grid, X, Y, N split. Does N split have to be a reference? Yeah, I actually want this to be an out argument. So we're going to make that a reference. And then we can increment it when we hit a splitter. And we want to mark places that we've been before. So grid X, Y equals a beam. Now the splitting, we're going to search to the left and to the right. G X minus 1. These all have to be references. And then X plus 1. That didn't work. I put the reference in the wrong place. It goes by the type, not the variable name. Something funny happened there. Stack overflow. Oh, we overflowed the bottom of the grid, right? Can we overflow the left or the right sides of the grid? Let's get some local sizes. If X less than 0 or Y less than 0 or X greater or equal to NX or Y out of bounds, okay, so let's print out that updated grid to see if we put the beams in the right places. That looks pretty good. And how many splits did we count? What's the right answer for the sample? I think it might have been 21. Okay. Let's try it on the real input. Takes a second. really takes a while. Well, we got a number. All right. I don't know why that's so slow. I could probably optimize a few things, but the complexity order I think is going to be the same. Maybe mark these as visited. Maybe we double visit those sometimes. We just have to. Now we might not want to double count. We might want to double count things because if you get to this splitter two different ways, those are two different timelines. Yeah, so it's not just the number of ways you can reach the bottom. That's not what we're looking for. It's the number of timelines, which is different from that. Okay, let's go back to the test input. Now, this might require some optimization because it might be an astronomical number of timelines because you basically double. Why is it 40? Kind of expect like a power of 2. So you can take a different path and end up at the same destination, and those are different timelines. Twelve, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Do we hit? Okay, so you don't actually hit every splitter. Right, we hit 21 splitters. So then why is the answer not like 2 to the 21? So here you have one stream, and you have two. I mean, I can try something naive for the test input, but I feel like it's not going to scale unless I get smart. We have one timeline. We have two timelines and still two timelines here. So the ways you can get to this row, go all left, go left, right, go right, left, or you could go right, right. So that's 4. One, 4, and then still 4. So we have 1 on this timeline. There's only one way to get here. There's 2 different ways to get here, and there's 1 way to get there. So then, no, this is like Pascal's triangle. Right, you have to sum the things above yourself. Just give me a good image. Why is it not like the first thing on Wikipedia? I mean, it's that image right there in the Copilot result. It's this one. So like this 2 is the sum of the things above it, and this 3 is the sum of 1 and 2. So it's kind of like that. That's how I'm thinking of it. So we have 1, 2, 1. And now the timeline's here. This is 1, because there's only one way to get there. This is 3, because you have one way to get here and 2 ways to get here. So you have 3 ways to get here, I think. And then this is also 3, and this is 1. So 1, 3, 3, 1. That's a total of 8. And this is also 8. And I think we can continue that way. Yeah, so we can sum up like a quasi-Pascal's triangle, and I think that should get us the answer about as efficiently as we did part 1. This line looks like it gets kind of funny. All right, let's try this for the test input. And part 1 was not particularly fast. I think there's a smarter way to recurse. You don't necessarily need to recurse for every step you move. You could count like these 2 as one recursion call. You could keep going straight down within one function call until you hit a splitter, and then you don't have to recurse quite as deeply because there is some cost to the recursion here. Like I'm re-getting these sizes every time and I'm doing all this bounds checking. So the recursion can get expensive. I'm gonna leave that to-do note in there. Now let me take, I think I'm gonna want a different search function for part 2. I think I'm just gonna call it search 2. So let's take part 1. We're still going to do all the parsing the same way. And we're going to have also, besides the character grid, we're going to have an integer grid to sum up these Pascal's triangle things. So let's try to do that. And then at the end, you just sum up everything on the bottom row, and that should be the answer, I think. So this is part 2. Let me take all my searches and call this search 2. Then let me copy my search function for part 2. Now I think this is actually breadth first search, and that's what I want. Because I think I want to have all the rows above me set. so that I can sum up the Pascal triangle correctly. All right, so let's try that. These might be big numbers. Okay, I didn't really do anything yet. So every time we pass G, we're also going to pass IG. So that's going to go into the function signature, and it is a reference to an integer matrix of rank 2. All right. So every time I update G, I probably also want to update IG. Is it just this? There's got to be more to it than that. Let's see what that looks like. They're all ones. That's... yeah, because the search doesn't multiply visit things. So if you're going straight down, you can just increment by 1. After you get split, I think what you want to do is you want to sum up and to the left and up and to the right, and then use that result to increment your current position. So where do I do that? X left and X right. What are we going to do here? So this is above and to the left of XL, and then we're going to do above and to the right of XL. And then similarly for the other place that we're about to search. I don't know if this is the right place to do this. And then let's try incrementing here. So then maybe I don't want to increment there. I think these are going to conflict. What's this going to look like? Non-integer. Oh, I think they have to R. What the hell? It's 1. Okay, so we got a 2 here. And that's wrong. Those should both be 1s, because there's one way to reach each of those locations that are non-zero in this line. So you have a total of 2 timelines on this line, but we shouldn't have 2s here. So I actually don't want to increment there. When you go straight down, you just inherit the count of the spot above you. So like that. Why did, because this might overflow now. If y plus 1 is less than ny, then we can safely set that. And it's all zeros. I think we want to start with 1. So three. Why is this 3? Maybe I should search the grid and then try to fill out the counts. Would that be any easier? I don't know. I feel like I'm committed to this approach right now. That's worse. Okay, so from here we split. This is 1, that's correct. That's 1, that's correct. But when we go here, the first time we reach this, one, 2, 3, 5, 6, 8, 11, 15, 17. Yeah, so if I just sum these up, I get 17, which is not 21. So this is definitely not right. Yeah, what if I just search the grid like part 1 and just fill out the bars? And then make a second pass where I put numbers on everything. Like this is 1, this is 1. Maybe that's easier, because then I just have to iterate over the whole grid once. I don't have to like do it in the middle of a recursive search. I think that might be easier to think about. Yeah, I'm gonna switch approaches here and try that. So let me copy a backup. Main v0. And then I might also want like a visited Boolean. BG for Boolean grid. Let's only pass the Boolean grid to search to, and still the character grid. So this is a bool. True, so those become true. And we also want to mark the splitters. We're going to do this now. So actually, I just want to set this up here once, and that covers both cases. Okay. So now you have true, 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 true. You have 5 trues in a row on the 5th line. So 1, 2, 3, 4, 5. Yeah, so the 3 pipes are visited and the 2 splitters are also visited. So you have 5 trues on that line. Okay, now let's make a second pass, a single pass, not a recursive crazy search over the grid after searching, and then fill out these numbers. So, this should be all zeros at this point. I just want to make sure I haven't set anything. Haven't even declared it yet. Okay, well, oh, no, not here. In part 2. I think this exists. Okay, all zeros. Now, we're going to mark the start location. So IG x naught y naught equals 1. Yeah, and from there we're going to iterate. So we're going to iterate in reading order. That should work. As long as you iterate from the top down. It doesn't matter whether x goes to the right or the left, I don't think. So this is 1. And anytime we have something above us that's visited, we're just going to inherit that value from straight above. And then whenever you go to the left or the right, you're going to sum your diagonal parents. And I think we can do this in one pass now without worrying about recursion, and this should be easier. So the sum is actually going to be IG all the columns of the last row after we do the processing. I just want to get my answer in there. Yeah, I want to have my while loop outermost. Now, if not visited, continue. Now, we don't want to, we want to skip the first row because that's going to have overflow issues because we're going to look at the row above, and there is no row above row 0. So if directly above us is visited, then we just inherit that value. Else, we're going to sum the diagonal parents. X minus 1, and always the row above, plus x plus 1, and still the row above. Let's see what that does. That didn't do anything. Why? Well, that's not right. But I don't think that's my problem. Am I printing this? I'm just not printing this. Oh, I have a 21 there. Do I have a problem? I have a problem here. So I still have overflow problems. And that might be... I don't have an overflow problem until here. So I don't think this is my only issue. Because if I have a 21 here and non-zeros in other places, I'm screwed. My answer is too high. One, like this is what I expect for this row. It's ones and then a 2 right here, because there's 2 ways to get here and there's 1 way to get everywhere else. And then this row is the same as the one above it. And see, it's summing like Pascal's triangle. So where do I go wrong? What's going on here? And then the numbers get misaligned because some of them are 2 digits, and it gets very hard to read. So I think this was 3. So that's why we have a 3 in the middle, and then this one is 6. Six, 3, 4. How many non-zeros do I mean, I should get that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. What? Split a total. Wait. 40. So it is more than 21, but I'm still wrong. Let's fix these overflow problems. X plus 1 less than nx. X plus 1. Went from 57 to 56. That didn't help very much. But these ones are... I don't know where I'm going wrong, but these are, I think, correct now. 56. Is this a different example? Example above. So 3, 1 splitter, 2 splitters, 3 splitters, and then 3, but one of them is biased to the left. Is this the same input as part 1? I think so. Then we have 4, and 3, a little bit biased to the left. 4 and 3, and then 6 with some uneven spacing. It's the same example, right? Yeah, that looks the same. Is my Pascal's triangle idea just totally wrong? Yeah, I think there are probably some spots in this densely packed region where it might be wrong. So here you want to sum the diagonal parents. Here straight up is active, so you just inherit that. Oh. Yeah, this one is funny. But I feel like my answer should be too low. And I'm having the opposite problem. My answer is too high. The right answer is 40. I'm getting like 56. So what do we do differently here? So we got split. Yeah, it's if there's a splitter to your left. If there's... Okay. So if there's a splitter to your right, you want to sum the right parent. If there's a splitter on both sides, then you want to sum like all 3 of these, because potentially you could have a beam coming straight down as well. Okay, so my logic is a little bit off, but I think we should be able to fix this. So I think everything should be fine here. And then nothing happens on this row, really. It's just all straight down. But I think I get it wrong on this row. So yeah, I think all of this is wrong. Because just because directly above you was visited, that doesn't mean you don't have split stuff to sum in. Now, if we have a splitter to the right of our current position, we want to sum the rightward parent. And we have to be careful with bounds checking. So that's one side. And then I think we have to do something similar with the other side. X plus 1 is less than nx. And this should be greater than or equal to. So this was wrong, actually. But I think it was wrong for multiple reasons. I think this approach is better. Plus 1. If that's a splitter, then we sum the parent on that side. What am I doing here? If, not IG. X plus 1. What does that do? 40. I think we might have it. Let's try the real input. Remember, it takes a second, and it's going to do part 1 first. It takes several seconds. I think I've got this, though. I think Pascal's triangle is the right idea roughly, but I just didn't have it exactly correct. This is part 2. I don't know, what was that, 10 seconds for part 1? It's going to be another 10 seconds because this final one pass summing for the counts, it's trivial after you've done the search. And I could probably optimize the search, but I don't know if I'm going to bother with that. Whoo! Yeah, buddy. That was just about the longest day so far. Nice puzzle. Let me put in some notes about how this could be optimized. First of all, it's probably better if you just do like a stack-based search without recursion. I think that's what's slowing me down. If you just push things and pop things off of a stack to search, that's probably even better. And it actually doesn't matter if you do depth first or breadth first, because I'm doing the count afterwards. This applies to part 2 as well. Search 2. So this is way slower than it needs to be. Don't need to do that. I'm going to delete that to-do note. So this is the only thing that I would really want to clean up. Let's also clean up the prints. Keep that one. That's the answer for part 1. All right, let me make sure that still runs, at least for the test input. Okay, 21 and 40, no extraneous logging. So I think I'm ready to commit here. And like I said yesterday, I'm still going to push my inputs, but I'm going to encrypt them first. I'm not going to wait for that to run because it's too slow. So encrypt the input and encrypt the test input too. Now this is not readable. And might as well explain what else I was thinking last night for day 6. Yeah, I think that was day 6 yesterday. Like 2 hours after midnight, like well after I had finished this, because I still finished it fairly quickly, I realized you can just transpose the character grid. So if we look at day 6, if you just transpose this grid of characters, character by character, you end up with 1, and then you would have 2, 4, but transposed to have 2, 4 in these 2 places. And then 3, 5, 6, actually wait, 2, 4 would be transposed down here, but they would be like in order as numbers in a normal string, not like some weird column-based string that you have to post-process. And then this other number that we're looking for, 3, 5, 6, this would get transposed to just down here. So that would probably be a lot easier. And I did like a character transpose to prove to myself that that was correct, but then I didn't finish implementing it, and I probably won't, because it's not like it's slow or anything, but it would just be cleaner, much simpler code. So that's in there, but I renamed it so that function isn't even called. But those are some final thoughts on yesterday's puzzle. Okay, how many times have I just run get status in the last 2 minutes? Probably too many times. Day 7. All right, we'll push that. Possibly we might think about a raid here if I have any viewers. Okay, so there's this diff from day 6 because I was messing with that, but it doesn't actually do anything. I have my input, but it's encrypted, so I'm abiding by Eric's rules now. I am in accordance with the terms of service for Advent of Code. This is just some junk version. I should just delete that now. And yeah, here it is. Here's part 2. So the search, I did add this boolean. I don't know if we really need that. You might be able to do it without that. But I did happen to use the boolean grid here for visit marking. I should have just deleted this off the bat. So that wasn't too bad. And like there's no recursion here. It's just one pass over the whole grid. All right. Let me see if I have any viewers. Nope, just myself, I think. I don't really understand. If I'm just looking at my profile, like it shows a preview of my stream, and then it shows 1 viewer. So I think it's counting myself looking at my profile, but maybe there is somebody out there watching me. I'm not really sure. So yeah, I'm not going to bother with a raid. I'm going to call it a night. So thanks to everybody who tuned in. I really appreciate it, and I will catch you next time. Bye.